Okay, so the last time that we were here, we were discussing the database diagram drawing for the Budget and Financial Goal Manager, and so we're going to talk about the Week 10 update as of now. So there were two major goals that I wanted to have accomplished by this point, which is to have the database that is functional, and also be able to do calculations and aggregates on some dummy data. Obviously, you don't want to use official information. And the creation of the database has mostly gone pretty smoothly. So VS Code has been the IDE of choice to work with MS SQL. And Docker is what I use in order to create server instances in order to be able to actually create an instance of the database itself. The tables and the conditions are able to also be created smoothly using create table, add constraint, and all of that fun stuff. I did initially have an issue where some of the tables or some of the entities were not happy, or SQL Server was not happy with the syntax. It turns out that some of the table names were actually reserved keywords, so I made the decision to change the names of some of the tables to be slightly different from the reserved keyword. I could, if I wanted to, use the same name as those reserved keywords by enclosing the name inside of square brackets, so that way it would literally call the name of the table transaction and not think it's the transaction keyword. But I didn't want to have to deal with that hassle throughout the entirety of the database management process, as including square brackets everywhere could be cumbersome, to say the least. So all of that was fine. The questions that I started encountering were when I started dealing with the subtyping and how exactly to go about doing that. So initially, I thought this wasn't going to be a major issue. And it still isn't. I have a much better understanding of what I need to do now. But when I first started working on integrating the subtyping in SQL Server, funnily enough, a lot of the references that I was using, they didn't necessarily have actual physical code for me to look at how to actually implement inheritance inside of SQL Server or any other database for that matter. So, just as a recap, we have several sets of subtyping going on here. So we have two major typings: financial transaction and account. So under financial transaction, there are two children. We've got the income and the expense, and the expense can take the form of loan payment, credit card payment, or it could just be some other financial expense as well. So and any expense doesn't necessarily have to be one of those two things. And then the accounts are split between bank accounts and the investment accounts as well. So surprisingly, when I was going through looking up exactly how to implement subtypes in SQL Server, it turns out there's not actually a formal way to do that, per se. As in, there's no subtype keyword, or there's no inherits or extends keyword, like something that you would see in something like Java or C# or anything like that. So that was quite interesting. Instead, the way it's usually done, at least from my research so far, is that it's usually done through the use of tables and using primary and foreign keys in order to connect the tables together. Kind of like how you would do a normal is a relationship. And, at first that didn't seem like it'd be too bad. But the way that you have to go about doing it, you have to be a little bit careful when you are working with subtypes. Especially when you start having subtypes of subtypes. So, as I was conversing with my AI agent that I've got set up with Grok, I was, there were three recommended methods to implement the subtyping. There's the single table inheritance, class table inheritance, which is probably the method I'm going to go with, which is the second method, and then there's the concrete table inheritance. So I'm going to go over those really quickly. I do want to preface this, the code that you're going to see was generated by Grok. No, I am not just copy-pasting it directly into SQL Server. No. The single table inheritance is the simplest way to do it. This is basically create one single big fat transaction table that just contains everything. It contains all the stuff regarding expenses, all of the stuff regarding credit cards, all of the stuff regarding income. It contains literally everything. So instead of having multiple different tables or entities for each of the different subtypes, we just have the one big fat typing, which is the transaction. I'm personally not a fan of this, even though this would be very quick to implement. And if we were making this database for very long-term storage, then when you're dealing with long-term storage, it's often best to prioritize speed as opposed to normalizing the database. So in that case, a single table might actually be the way to go if you're just focused on speed and nothing else. But I'm personally not a fan of this this way, as it seems like that this command, this one big fat table, is trying to do way too much. It's like trying to define a function that does 10 different things at the same time. That's not very efficient. It leads to unexpected behavior, and so I personally would want to split this apart into smaller pieces. And the way that I think I'm planning on doing it, and this is the way I was thinking about doing it initially, is to use class table inheritance. According to Grok, this is the most academically correct, whatever that means, and this is, but I think the more realistic answer to this is that this is probably the most similar fashion to how you would design classes and superclasses and subclasses in something like C# or anything like that. There is a major problem with this method, though, and that is that any queries that need to be done on these are going to require the use of joins. So that is something to keep in mind with this table, and that is one advantage that the single table version has over the class table inheritance method, and that is for the single table, it's really stupid easy to write the query, and it's very fast. This will require the use of joins, but I still think that this is probably the method I'm going to go. The final method that was suggested is the concrete table inheritance method. This is basically where it requires a definition for a separate table for each leaf or each part of the subbranch of the subtype tree, and it also requires duplication of columns. I'm personally not a fan of this because doing this would require updating not just one table, but numerous tables simultaneously in order to make any changes to the data, and I think this would just overcomplicate and make the database more clunky to use. So I think personally the way forward is to use the class table inheritance method, even if it does require excessive use of joins. But that is where the project stands at the moment, so once I get over this hurdle, the rest of it should be fairly smooth to finish off. So with that, that is the current state of the project, and that's where we plan on heading next. So thank you guys for your time.